Okay, when we're having to solve one-step equations, solving equations, and I've got several up here, requires first us to understand the order of operations, okay? Order of operations, and as we get into bigger things, sometimes you get really big equations, you got to do a lot of stuff with them, okay? When I'm solving just a simple one-step equation, it's pretty straightforward, but let's talk about how I can simplify things down to a one-step equation, okay? Having things that are big and complicated, simplifying expressions is an important step, and make sure to take some time and look at that video with it, because the simplifying helps make a multi-step equation into a single-step equation, okay? Now, as I do these single-step, I'm essentially undoing any one part of it, okay? So each of these only have one part going on at a time, and so I have to undo it. Now, some of these are really multi-step problems, but they look like single-step as I look at them first and foremost. So this first one, 2 plus x equals 8, okay? Now, as we introduce the idea of solving, we need to do it with problems that have to require some level of thinking. As I look at this and you look at this, you think, oh, I know what x is. Automatically, our mind, because we've done so many of these, starts to answer these problems automatically for us, okay? So, requiring students to then show me how it all works out, that is what needs to be the focus more than the step or more than the final answer. Showing the steps is what I'm actually going to give them credit for, okay? So on this, I need to require that they use this -2, okay? Why am I minusing 2? Where did I pick 2, okay? I want to go opposite of this. The whole goal in solving any equation is to essentially be adding 0 or multiplying by 1, okay? Why? Because these are the additive identity and the multiplicative identity. If we can add 0 and multiply by 1, we aren't changing the in value, so x can be all by itself. It's simplified in its easiest way. Okay? When I'm adding or subtracting, that goes to individual aspects. This whole thing has the added 2, so I can just minus the 2 from that part, and it's affecting the whole thing. Okay? So then as I do this, this goes to 0, it cancels out, okay? Goes to 0, but that positive and negative canceling each other out. This comes back to our integers and understanding of those, okay? X then equals 8 minus 2 is 6, okay? Now with algebra, and especially any time that we solve for a variable, going back and plugging it back in, checking it, is an important part that often gets overlooked, okay? I've got my answer, I keep moving on, boom, 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 okay? Taking the time to make sure that that is the correct answer. Here I can say 2 plus 6 equals 8. That's all it took to check this work. Sometimes it's more to check that problem, but that, in this case, simple, easy to write. This problem, 4 minus x equals 3, okay? Now, in our mind, we can see what this comes out as, okay? But this, although it's listed as a one-step equation, is not, okay? In order to solve for this, we need to get x to be all by itself, meaning even no negative sign on it, or no subtraction sign. Similar to the problem before, I'm going to minus 4 from both sides, right? I minus the 4 because that's what's there. This negative continues to stay with the x. So I get negative x equals 3 minus 4 is negative 1. I have a negative x. I am not done. Although this is true, x itself is not solved for because I don't have x without a sign. It needs to be a positive x. So when I see this, and both of them have our negatives, I have to get 1, just 1, not negative 1, positive 1. So here I can divide by negative 1, then my negatives cancel each other out. Okay? Again, dividing by negative 1. This leads to x equaling positive 1. Okay? The negative divided by the negative cancel each other out. I get a positive 1. 4 minus 1 equals 3. Absolutely, I agree with that. If I had only stopped here, or if I dropped a sign somewhere in there, which is fairly common in the early work of students, then we would say 4 minus a negative 1 equals 3. Not true. Okay? So going back and checking the little bits all the way through. Okay? So here we've got multiplication happening. 4x. Okay? These combined terms are happening with multiplication. Okay? And so my opposite operation is going to be division. Well, what do? This is not an addition, so I don't want a 0. I want a 1 here. How do I get 4 to become 1? This is where we're dividing by the 4. Okay? If I do it on one side, I do it on the other, so that way this stays equal. If I do something to only one side, it doesn't mean it's going to stay equal. Okay? Only if it's adding a 0 or multiplying by 1, because then the value stays the same. These two have the exact same value. I want to break it apart and see what only the x part equals. Okay? 4 over 4 is our magical 1 in here. They cancel each other out, as we like to say. And we get x equals 3 when it's 12 divided by 4. Okay? So recognizing that the zeros and the ones are really our goal in all of these one-step equations, in all of our equations, getting more and more zeros being added or ones, that's simplifying, and I don't have to write that anymore, because really there's a 1 and here there's a plus 0, but I don't need to write that. Okay? Now moving into the division aspect, okay? A problem like this, when I see a fraction, all fraction problems are division, all division are fraction problems. So instead of x divided by 7, or x over 7, I want to think about it as x divided by 7. Okay? Now I have a methodology to undo. Right? Just like addition and subtraction are opposite operations, multiplication and division are opposite operations. So I want to multiply both sides by 7. This is like 7 over 1, and they will cancel each other out, right? And I always like to do that big 1. There are some books that will show that big 1, and that's an important part for it. Okay? So then x equals 12 times by 7, which is 84. Okay? Now, similarly, this and this look set up the same, right? There's a division going on. Both of these can be classified as one-step problems. But this, when you're dividing by x, just like when you were subtracting by x, because of the order of operations and the commutative property that says that division and subtraction have to be done in a specific order, this is not as easy and clear. Okay? Now, as I look at that, 8 divided by something equals 2. I can figure that one out in my mind. The answer is not the difficult thing here. Making sure that I clearly show all my work is the important aspect. Okay? So how do I deal with this? Oh, there's a variable on the bottom of a fraction. Well, what is a variable? Okay? A variable is a representation of a number or relationship of numbers and other variables even. Okay? So that follows all the same rules I would like a variable and a number. Sorry. Okay? So right here, I multiply both sides by 7. I can do that here with the x. Now kids are not as comfortable with that because we've always worked with numbers. But this variable represents a number, so it follows the same rules as numbers. So I can multiply by x on both sides. So that means when these cancel each other out, right, there's my 1, I get 8 equals 2x. Okay? These are essentially the same equation. Okay? X is the exact same value in both of these. Now I divide by 2 on both sides. 8 divided by 2 is 4 and equals x. Okay? Now, is 8 divided by 4 equal to 2? Yes, I'm plugging it back in. It makes sense that I can do that. So I have to be comfortable with variables being a number representation, right? And so they follow all the same rules. Anything I could do with a number, I can do with a variable, okay? And this, although it may be a one step, there is only one operation going on in there, but to undo it takes a couple of steps, okay? Now, real quick on this, 4 equals x. Is that the same as x equals 4? Yes, okay? Direction and order can be something that students get pretty uptight about pretty early on. So making sure that they're comfortable with 4 equaling x or x equals 4. Either way, you need to be okay to accept it, or if you're going to have them always say x equals something, you need to have a good reason for that, okay? This, just personal preference, not a real good reason, okay? There's not a whole lot of real solid reasons why you would never accept 4 equals x instead of x equals 4. But there are a couple of times when having it written with the variable on the left does give you a little bit more to help out and making sure that you can do the different things, as we'll talk about later on in inequalities.